Good day, everyone. Follow me. Let me explain to you what molecular formula and empirical formula are all about. All right. I believe you must have heard of empirical formula and molecular formula, especially the calculation aspect of it, and you will be getting confused how to calculate this, the difference, how to do it, how to go about this. Calm down. I'm here to help you, to explain to you how to do the calculation. They are not difficult. Let's go. All right. Today we want to talk about empirical formula, and we want to talk about also molecular formula. When you are talking about formula of a compound, this formula, for example, can be expressed as what? To its simplest form. Like this one, if I'm talking about maybe a compound that contains only hydrogen and what? Carbon, that is hydrocarbon. Maybe if I have it to be like this, maybe this is butane. I have butane like this. When I have butane, I have something like this. All right. So this is the molecular formula of butane. Why do I say that this is molecular formula? Because this formula shows the actual amount of carbon in this what? Compound. It shows the actual amount of what? Hydrogen in this compound. When you have something like this, you say that this is molecular formula. All right. But when you want to find the empirical formula of this, you have to reduce this to lowest term. You ask yourself, this 4 and 10, do we have anything that can divide? Yes, 2 can divide this and 2 can divide this. All right. When 2 divides this, you have this 2. When 2 divides this, you have this. Can you see that? You notice that now you have reduced this to its lowest term, which is this one. So this kind of formula, we call it what? Empirical formula. Why this kind of formula, we call it what? Molecular formula. So empirical formula of any compound is when the formula of that compound is expressed in its simplest term, simplest ratio to the atoms involved. As you can see, there is nothing that can divide in common between these 2 and 5 except 1, and when 1 divides, it will give you the same thing. Is it clear? So when you express a formula in its simplest form, simplest ratio form, you say that you have expressed it in what? In empirical formula. But when you write out the actual formula, the formula that will contain the actual number of atoms that you have in that form, in that compound, we say that this is what? Molecular formula. So this will reduce this to its lowest term, but this will give you the actual atom, actual number of atoms you have in that what? That compound. So that is what we call what? Empirical, and that is what we call what? Molecular. Empirical has to reduce to lowest term, while this molecular will give you the actual amount of each atom in that compound. All right, we have some calculations that are associated with this empirical formula and what? Molecular formula. Let's go ahead and solve, and that is what you students are actually finding difficult. I'll show you how this can be solved. So let's go ahead. We have example 1 like this. We have example 1. Example 1 says analysis of a sample of an organic compound showed it to contain 39.9% carbon, 6.9% hydrogen, and 53.2% oxygen. Calculate the A. Empirical formula. B. If the relative molecular mass is 60, what is the molecular formula of the compound? So here we are required to find the empirical formula and also the molecular formula. They are not difficult. Follow me. I'll show you how it can be solved. So we have solution like this. All right. So the first one, they said carbon. You write the chemical symbol of carbon. Next one, they said hydrogen. You write the chemical symbol of hydrogen. And the other one, chemical symbol of what? Oxygen. So the percentage of carbon, we have 39.9. Percentage of hydrogen, we have 6.9. This one, oxygen, we have 53.2. That's what you're going to write. Can you see that? So each of these percentage of abundance, you divide by the atomic mass of that atom. Like here, the atomic mass of carbon is what? 12. So I will divide this thing by what? 12. The atomic mass of hydrogen is 1. I will divide this thing by 1. The atomic mass of oxygen is 16. I will divide this by what? 16. When 12 divides 39.9, you have 3.33. When now 1 divides 6.9, it will give us 6.9. When 16 divides this, it will give us 3.33. Can you see that? All right. When you have something like this, you divide through by the simplest ratio. The simplest one we have is 3.33. That means that I will use 3.33 to divide this, use 3.33 to divide this, and use 3.33. You are dividing through by what? The simplest ratio. So we have this one. You have 3.33 all over 3.33. This one will give us 6.9 all over 3.33. All right, this one I will have 3.33 all over 3.33. When I divide this, I will have 1. I'm taking approximately whole number ratio. So when I divide this, I will get this. When I divide this, I will get approximately, I will get 2. When I divide this one, I will get what? 1. Can you see that? That means that I will have 1:2:1. This simply means that the carbon should be 1, the hydrogen should be 2, and oxygen should be what? 1. So I will write it like this, that this should be like this. Hydrogen should be this. Can you see it? And oxygen should be this. Can you see it? So this is what the empirical what? Formula. This is what the empirical formula. All right. This is our empirical formula. That is how this can be solved. Empirical formula. Can you see that? Empirical formula. All right. So let us solve our number B aspect of it. The B says that we should find what? The molecular formula. As you can see, we don't have enough space here. Let me solve it here so that it will be comprehensive enough. The B says if the relative molecular mass is 60, what is the molecular formula of the compound? All right. Okay, let me start from here, then I will now go over here. So I have B part of it like this. So what do? I will pick this empirical formula. We make use of empirical formula to find what? Molecular formula. What do I have here? I will put this in a bracket. So I have CH2O like this. Then I'll write N. Can you see this N here? I'll write N here. I'll say it is equal to this molecular formula that they get, this molecular mass that they gave to me here, which is 60. I'll say it's equal to what? 60 like this. I don't want to continue here. Let me come over here. All right. So we have this one. We have carbon to be what? 12. So and we have 1 atom of carbon here. So here inside the bracket we have 1 times what? 12. That is 1 atom of carbon times atomic mass of carbon, plus we have 2 atoms of what? Hydrogen here, and atomic mass is what? 1. Then we have 1 atom of oxygen, and atomic mass is what? 16. Then you have N like this. Everything will give us what? 60. I hope it's clear. All right. So here 1 times 12 will give us 12 like this. 2 times 1 will give us 2, and 1 times 16 will give us 16. We have like this. All right. So you add up this plus this will give us 14, plus this one you have 30. So we have 30 like this. Can you see that? All right. So when you multiply this, you have 30n is equal to 60. Divide both sides by coefficient of n, which is 30. You have 30n over 30 like this is equal to, we have 60 over what? 30. Divide this and divide this. You have that n is equals to what? When you divide this, you have 2. Divide this, you have 1. That means that n is equals to what? 2. All right. We have gotten the value of n. So for us to get the molecular formula, we have molecular formula. For us to get this, we'll go back and pick this. This thing we have here, we have it to be this. We have it to be CH2O. N. Now we have found the value of N, and N is what? 2. So we substitute, we have this CH2O, we have 2 like this. So 2 is multiplying this, is multiplying this. This will give us, because we have 1 here, it will give us C 1 times 2, this 2. Then it's multiplying this one also, we have this H 2 times 2. 1 is here, it's multiplying O, also we have like this. Can you see that? All right, and that will give us 1 times 2 will give us 2, we have C2. This one 2 times 2 will give us 4, we have H4. And 1 times 2 will give us 2, we have like this. Can you see that? All right, so that will give us C2H4O2. All right, let me clean this and finish it up here. All right, this simply means that we have 2 atoms of carbon, 4 atoms of hydrogen, and 2 atoms of what? Oxygen. So look at it here. So actually the formula we are talking about here is what? Is ethanoic acid. You have CH3 C00H. So actually it is what? Ethanoic acid. Ethanoic acid. That's what we are talking about. So look at it here. The molecular formula we have like this. Can you see? C2H4O2. So it's actually ethanoic acid. All right. I believe that you enjoyed the way I just solved it. Remember, this is Engineer Kenneth tutorial. Follow this page and share this video so that it will get to the right students that need to acquire this knowledge. Bye.